So in this video, I'm going to be showing you how to set up a console router combo on the Helium network. What's important about console router is it's basically a LoRaWAN network server that knows how to buy packets from hotspots on the blockchain. So it follows the blockchain, it manages state channels, and buys packets. What else do you need to know about this? Well, actually, let me start with the important part of the docs that you should maybe look at for some high-level stuff. So the LoRaWAN, the way it's done on Helium, is that primarily you operate under the Helium Net ID, which is a organizational identifier with the LoRaWAN Alliance. But what you do with the Helium blockchain that's pretty unique is there's this concept of multi-tenancy. We have created a system where lots of LNSs can operate under the same net ID, and you do that by basically registering your OUI on the Helium blockchain and getting address spaces and stuff like that. So you kind of have to think about the fact that actually I think there's a piece of the docs here that helps. Yeah, so this is the device address, right? And so you're operating under the Helium network. Actually, this is no longer accurate because we have an actual net ID now allocated by the LoRaWAN Alliance. But that's the top part of the address space, and that's an allocation given by the LoRaWAN Alliance. This lower piece is an allocation that you get from the Helium blockchain. So you get a range of network addresses that basically allow hotspots to identify who a data frame belongs to. So that's how routing for data frames works. For join frames, they are slightly different, where they have an app EUI and dev EUI, and the way we manage those is every single OUI on the Helium blockchain, which is the one of these sub LNSs, it registers filters in the blockchain that help hotspots know who might be interested in buying this join frame. So those are the two types of frames, the join and the data frame, and that's, there's those two ways of routing them. There's the filters with the app EUIs and dev EUIs, and then there's the dev adder slabs that give you this routing piece here. So that's kind of the high-level piece of it. So the next piece of the docs that we should start with is running a network server. And that's going to be really the meat of today's tutorial. We're going to go through the steps together and start up the server and work through all the little details that go into that. So the first step is, I guess it's important to know about the different requirements here. You want to have a couple things set up before you try to dig in on this. One is let's have a Helium wallet available with some HNT inside of it. So this is what I got here. I got 50 HNT. The next thing is I did set up an account with Hetzner. And so have a cloud account set up. You can use AWS or whatever. I wanted to feature Hetzner today because they're not AWS. What else do we have? I think those are the main requirements. We might run into something later, but that's basically it. If you need to figure out stuff about Helium wallets, there's this section of the docs here. The OUI management all happens with the CLI wallet. You can't these other wallets, the app wallet and the ledger wallet, don't really handle the OUI operations. But yeah, anyway, so let's start with buying an OUI. This kind of summarizes it again. What we covered in the beginning is an OUI is basically a requirement for you. You need an OUI if you want to be buying packets from hotspots. So the OUIs are allocated up to 5 filters, and they're allocated slabs, at least one slab of dev adders, but you can buy more of them. Something that's probably good to know just for context. So The dev adders, you can buy a slab of 8, but we actually, something that's special about our LoRaWAN network server is we multiplex lots of devices on the same dev adder. So there might be 50, 100, 500 devices that have the same device address. But when you receive that data frame, you can actually figure out which device it is actually uniquely from by analyzing the message integrity check, the MIC. So you basically kind of brute force this packet to figure out which LoRaWAN device it actually belongs to, and because of that, we can be really efficient with our device address space here. And so you can buy 8, and you can probably get pretty far with that before you want to buy more. The reason I mention that especially is because each device address is $100 in data credits. The OUI itself is only $100, but basically you want about $900 to get started today, because you want to buy the OUI itself, and you want to buy the minimal device dev adder slab, and the slabs have to be bought in powers of 2. 8 is the smallest. You can also buy a really big slab. It'd be pretty expensive there. But yeah, so let's go ahead. I already have my wallet set up. Pretty much just going to do this. Actually, you can ignore the filter because I think it gets populated by default now. So I just typed in my password. It's going to just present the transaction to me. I'm going to confirm I'm buying, the previous OUI was 21, so I'll be OUI 22. The subnet size is 8, and I haven't quite given it an address yet, but we will do that part later. So let's go ahead and buy that OUI. Oops. So to actually submit the transaction, you want to do commit and then type in your password. And this time it'll submit it to the blockchain. One detail to know about is that so I had an HNT balance of 50, and I had 0 data credits. It's gonna check the on-chain price of HNT and convert my HNT with this transaction so that I can pay for the device address and OUIs. So you can check the current price. It's about $21.7. So whatever that is in HNT. So $900 divided by 21.7. That's going to be about 41. It's going to take up most of my HNT normally. So also something to know where if you want to track this transaction, you want to go back to the API and check here. So we see it's pending. In the meantime, let's just spin up our server and get that going. So don't mind the prices in euros, but they do have a US-based product now, which is nice. I'm going to go ahead and pick Rocky Linux, which is a flavor. It's kind of a CentOS derivative. And their dedicated product is pretty competitive, so I'm going to go ahead and grab this guy. So I got 4 cores, I got 16 gigs of RAM, 160 SSDs. That's pretty good, I think, for this, because you want a fair amount of space because you will be syncing the blockchain, and you'll run out kind of fast. Anything smaller than this, I think. I'm actually going to beef this up because I'm not going to run this for very long. Yeah, that'll be more than enough, and I really shouldn't run out of resources here. So I'm going to go ahead and create and buy. So the reason I'm spinning up this server is because the next step in this whole operation is, actually let's go back and make sure we're following along with the docs and I'm not skipping anything. Buy an OUI, that's happening. and then run console. So console is this LoRaWAN network server, or LNS for short, along with a kind of device management backend and front end for managing that, and it has a lot of other features that you can read more about here. I won't be going into any of these today because that's a whole other tutorial. But basically, Helium Console. You can manage your devices, you can manage data flows, you can connect, you can use all these different integrations that exist. There's there's basic ones like HTTP and MQTT. There's also more like full integrations with other people's backends like AWS and IoT data, and then Google Cloud, no, Azure is the other integration. So lots of options there, a lot of depth there too. So we're not going to be touching into that. But we're going to be doing run console, purchase an OUI, install Docker, Docker Compose, and yeah. So we got this fresh server. I think they're going to give me a password for the first login. Yeah, they emailed me the password. So I'm going to go ahead and drop that in here. They want me to set a new password. I've used my unsecure password and they didn't like it. Cool. So now I'm on a server in Virginia. Let's see if I've purchased an OUI. Let's look at that real fast before we go on. So we're going to go back here and check the balance. And yeah, pretty much what I anticipated for cost. And now, oh, it doesn't list it for me, but what if I do update? Okay, so we'll touch on that later, but I am now the proud owner of that OUI. If you go over here, OUIs? Yeah, okay. So there I am, owner of OUI 22. That's pretty much it. Alright, so I'm back to start setting up my server. So I'm going to log back in with my bad password. And when I was provisioning the server, I chose Rocky Linux, I believe. So if you pick any of these CentOS, Rocky, or Alma, there's some kind of quick setup stuff you can steal from here. I'll go ahead and get these running, and then I'll talk more to that in a second. So most of it's most of it's just getting Docker to run. Docker Compose has some Python dependencies. I've added a couple of utilities that I like to have, like NetTools, HTOP, Vim, and Git is necessary too. But the rest of this stuff is pretty straightforward. Once the server's done getting set up, we'll go to the next step. So we're back. Let's see. It looks like when I copy-pasted the whole thing, not everything went. Still have to put in some more. And with Docker installed, I can enable it. I can start it. We can check that it started okay. It looks good. And finally, I'm gonna download the latest release of Docker Compose and give myself permissions to use it. So that's basically everything that was needed to prepare a CentOS-based system. Now I'm going to clone console. The next step will be to customize the environmental file. So we're going to create a couple of keys mostly, and then give it our host domain, And then we're going to set up the auth system. So let's get started. I'm going to open up another window because it'll be easier to copy and paste that way. Let's see. So we're going to do this. Let's go ahead and do and I'm feeling kind of lazy, so I'm going to use the same key just about everywhere I can. I'm not sure why it's in 2 lines. We'll do it here as well. And then for this one, I'm just going to plop this on the end. And then I'll go ahead and I'll need a timestamp as well. So let's grab that. Go ahead and put that in the beginning. Great. And then we need this a smaller key secret. Oops. And we'll tack that on here. All right. That's cool. The only thing left now is my host domain, which I believe is just localhost. Let me go back to the instructions here. Environmental domain. Oh, they want 4000 at the end. Env domain. Next will be socket check origin. It's going to be the same thing as this. So this will be different, by the way. This tutorial just is teaching me how to set it up locally. I'm doing it on a cloud server, but I'm setting up it locally, kind of as a test situation. There'll be a trick to that later. But there is another tutorial, just so you know, that changes things slightly. Actually, maybe the menu will show up. Yeah, so if I go wide enough, I can see deploy console, and that's different than running console, because deploying it goes through some of those little extra steps that makes it a more reasonable, like, production level setup with security-wise and stuff. But we're taking a bit of a shortcut today, just to keep things simple, and get ourselves to a working router faster. So OUI is going to be 22. It is self-hosted. We're not using auth0. We're going to use magic auth. And actually, I did forget to mention that in the beginning. So if you go to magic.link, you'll want to have an account set up. Okay, leave me alone. Acknowledge. Cool. I'm going to do a new app. Set up console. And we'll just take this publishable API key. That's the public side. And then secret key. And that is it. There are some other features to know about, like setting up email alerts, and Mapbox I think is when you look at gateway management on console. But that's basically it. So we'll go ahead and do that. Next up in the tutorial is okay, we did that. We did magic auth. Router. So the only thing that matters for the router setup is getting the router secrets copied over from this file. So I'm going to go ahead and take that from here. Make sure I have it. Alright, I have it copied. I'll go ahead and do this. Copy it over from templates. I'll go edit it. And I'm going to look for router secrets. Right here. And we'll go ahead and paste what I have. Oh, oopsies. Let's go take that again. Oh, I took the name with it. So I want to keep the name from this file. Okay, so that's the really important thing. It is good to know about this file though, because there's some kind of like some important variables you could configure that allow you to control some details about how router works. But that's a little too deep for today. Okay, so the next step is we've set up our environment files for router and console. We're gonna copy over this template for Docker Compose, and so this Docker Compose file, in case you're not familiar with them, it basically describes the containers that go into your system and how they go together, who depends on what, and so on. So what you can read here is there's one service called console. It has a certain image name, container name. The port 4000 is actually for the UX, and it depends on Postgres. Postgres is the next container, and similarly it describes some things about that guy. We could start this up, except what I'm going to do first, and this explains it in the tutorial here, is I'm going to swap out the image for console. The reason being that I don't want to build it. So if I leave it like this, it'll build it. So I'm just going to go ahead and delete these lines. I'm going to plop in the line I like. You got to be careful about white space with this. And the next thing is also, I was testing this earlier today, and the router tag latest is broken, and that's it's not really our fault, right? At least this time it's not our fault. It's K's having some issues lately, but if you take an explicit tag, at least right now, it'll work. In case you see the issue, it had something to do with the pub key being invalid. But we're going to work around that just by being specific about the tag. And then just remember these ports. 4000 is important, and then 2154 and 8080. We're going to open those up in our firewall in a second. So that is that. I should be able to just start up now. So I'm going to let that run. Actually, it'll be pretty quick, so let's just take a look. So it's creating the database. What else is it doing? That does take a little while. You see these crashes from router. That's okay, because it's just waiting for console to stabilize and be done. The database gets initialized. There's some migration logic, but this is a fresh build, so it's still running just to kind of make sure everything's good. Whoop. And it looks like router stopped crashing. This is what it looks like when it stops crashing. Console is doing its thing. That's good. Cool. And then the next thing, I was doing this earlier, so there'll be some leftovers, but we'll go ahead and delete this and I'll do it again. So we're going to create a firewall. This will be different on every provider, but this is on Hetzner. We have SSH on port 22. We're going to add the libp2p port, which was it's TCP on 2154. And then we'll do gRPC on port 8080. And we'll create that firewall. And let's just look at that again and see if it looks okay. So, yeah. The next thing to do is that port 4000. I'm going to run this command here. And what it will do is take port 4000 from our remote server on Hetzner and map it to my local port 4000. So I'm just going to go in and you can do this with a variable or whatever, but just to make it very clear what's happening here, I'll actually change out the variable with the IP. It'll prompt me for the password. Boom. Okay. So, this is the moment of truth now. If I go to localhost 4000, I'd hope that I would connect. And it looks like it's being responsive. You can see back here, there's some stuff happening. I was logged in earlier, so it kind of skipped something I wanted to show you. So, if I hadn't been logged in, I would have landed here. So, what I'm going to do instead is log in. Do not try to use the Google login unless you've done extra configuration with Magic Link, because I haven't done that, it won't work. So now I'm on my next step, which is to check my email and click on the link. So I clicked it, I'm logged in. Now I can create an organization, or let's call it widgets. Okay, add organization. Now we're up. Cool. So that's all good. I will. We're going to proceed to the next step now. I will create a new device just so it's there. Test device. We'll save that. And it's going to be pending forever unless I do stuff now. So I'll leave this because I think it's nice to see what's happening. I'll take a new terminal and I'll work down here. Actually, my face is down there, isn't it? So I will cover this guy up for now. But so the important thing is, so we want to, we haven't registered this actual this router as a location, as the OUI operator, basically. So just to maybe, hopefully this will make it more clear than what I just said. So, oh, that's production. Yeah, so on production, or on the mainnet, you'll see that there's the owner, which is the wallet that purchased the OUI, but that's different than the keys used for the addresses. And the reason is these keys on the server are hotkeys, and you don't have to worry about them getting, or you don't have to worry about your OUI getting compromised as much, because you can always reallocate who is managing this OUI for you. So what I'm going to do is first I'm going to log into my Hetzner server, and I'm going to figure out what my public key's name is. So, or what my key is for the okay, Docker containers, container ls. So these are all my containers. I want to interact with the router one. So I can do docker exec, the name of that one, and I know that the executable is on this path. So let's just let's check that. There. So just to sum up this command, I'm basically saying I want to execute a command inside of this container, and then I'm writing the path of the router executable, and then I'm sending it the command what's your peer address. So with that information, I'm going to go ahead and take that into my pad. Now I can do OUI update. Let's see. I'm doing routers, and I'm putting this guy in. So let's review this, hopefully. Oh, I gotta be explicit about the OUI being OUI 22, and the address being what I just wrote. So I can review the transaction. Last OUI though. Let's see if this is the right one or not. We'll know pretty quickly because the transaction will fail quickly if I'm selecting the wrong OUI. Let's take the hash, go to pending transactions, and it's pending, which is a good sign. It didn't get rejected by the API, who would have seen that you don't own this OUI, so you can't do this. Let's just check one more time to make sure. Cool. So that's promising. The second thing we're going to do is actually give some money to the OUI. So if I check my balance, I'm at 8.5. So let's go ahead and do a burn transaction. Let's do about $100, which will be most of what I have here. Let's go ahead and do that. I'll need to leave behind some HNT just to cover the transaction fee, but that's probably even too much. How does the burn transaction work? So I got to do the amount, 8.51. I'll do the payee, and I'll put in this address here. And just so that you understand how the burns work, they're not transferable. So make sure you're burning to the right account. Once the DCs are there, they can only be spent doing things that you spend DCs on, primarily, in this case, operating a state channel. So let's just review the transaction. And that looks good to me. Let's go ahead and do it. So, okay, we've got this key going. The next thing I'm going to do is log into the server, and I'm going to see how the container is doing. So earlier we did pure address. Now I want to check info height, because the thing I'm concerned about now is how far along is it syncing the blockchain, and because I won't be able to really operate the state channels and do anything useful until I catch up. So if I go to the Explorer now, I can see that I'm only 100 blocks away. That's pretty good. So I'll probably just let this go. It's syncing okay fast. Let's see how those cores are doing. But yeah, I think it's close enough that we can just be patient and wait for it to sync. Let's keep the cadence. One thing. So I'm going to wait for it to sync. It should be able to do state channels and stuff like that, and it's going to be useful to be able to to test. By the way, this is just what we went through, just to recap. So I created data credits. That's what this is. I did an OUI update for the address, and that's good. So let's do a test device. I already created that. So what's going to happen is once I catch up the blockchain, and once these two transactions clear, the OUI address one saying I can operate on behalf of the OUI, and secondly the DC burn transaction, then I'll be capable of updating the filter on the chain. The filter is what's important for the join requests, and that's what's pending here. So this will say pending whenever console thinks that the filter containing a device hasn't been written to the chain. So the next thing is going to be to test this easily. So you can use a physical device if you have one, but what I like to do is play around with virtual devices, because it's which gives you a lot more flexibility, and it means you kind of have you have more visibility on what's happening, especially. So if you go back to the docs and make this a little wider so I have the side menu. Run a network server. We actually do talk about debugging with a sniffer. I don't think we're going to go that deep, but what we will do is the virtual device part of it. So you can do the compilation but I think what I'd like to do today is just use the release. So let me see, tags. If I go to the most recent release, I should have a download. Oops. I probably have to go wide again so I can get back to the menu I'm used to. Tags, downloads. So yeah, you have these quick and easy downloads here. I'll go ahead. Let's check this one last time before we go. Okay, getting there. All right. So we'll go ahead and download this. We'll extract it. By the way, you follow the tutorial if you'd rather. If you know how to do this, then this will be faster. But if you don't know what you're doing, the tutorial will get you there as well. So, oops, virtual LoRaWAN device. All right, so we're in there. Oops, I went into the source code that I had downloaded already. I'm in the release now. So, I don't quite remember how everything works, but we're gonna figure it out. Ah, looks like the README isn't here, but it's saying I'm missing the configuration file. Okay, so I will go to the README on the repository, and basically I know that I can just initialize it with this settings. Let's see, make directory settings. Oh, there's no default either. No, well, that's my fault. I should have that packaged in this release. So I'll go ahead and grab it myself. So this app basically lets you connect a device directly to the network. That's all software based, so that's why I like it for testing things out. It can be one device, it can be many device. They can appear to connect through lots of different packet forwarders. So it's really good for testing things out. Now that I have the default, I got to do settings, and I'll just copy this as a template. But then I'm gonna take my stuff from the dashboard. There it is. So this device, once it's on chain, I'll be able to take this credential. So the dev UI, just paste that in. App UI, paste that in. And the app key. All right. And then I can override. So there's also another shortcut here. I can basically change the so the shortcut here is if I wanted to do this from scratch, I need to create a gateway, a light gateway instance. There's actually a service that you can use that lets you throw packets into the network without bothering with that. The downside is you don't earn the DCs that you'd otherwise earn, but it is practical. So I'm going to go ahead and set that up. I'm going to change this to something else in case I have something connected. So I think the URL is us915 argon.build and then port 1681. And so that's basically a light gateway running that I can connect to and send packets into. But let's see if it works at all. Oops. So we're going to just run the utility. So it looks like it's started up. I don't quite know if the connection, I think the connection is looking good, but we're likely still waiting for this thing to sync. So now that we've done this setup, I basically have this device just like constantly sending a join request, which is the first step to a LoRaWAN session. It's not coming through, but do not fear. All right, so I took a little break, like it was 20-30 minutes. if that. And my height is looking good. I'm at 127.6010. When I go to the API, it's right around there. I'm actually a little ahead of it. So I should be synced. But I'm going here and I'm going to refresh this to make sure there's nothing stale. I'm pretty sure that the pending thing updates. Still no good. So what I'd like to do now is get just a little more insight on what's happening. My height looks good. How am I doing? Let's see. So there's a lot of stuff on the command line with router. Is it filter or filters? Filters report. Let's see what that does. Oh, that didn't work out. Probably because there's nothing on chain. So how about update? No updates. Okay. Let's see what else we had on that menu. Alright, well let's just look at the logs. Let's start with that. Let's see if we're, because what's nice about the logs is we'll see. Oh, let me actually be a little more clear about what's happening here. So if you look at the Docker Compose, router saves data inside of this directory. Data/router is the var data from inside the container. So I know that in data router, there's a log directory called router.log. And so if you follow this, you can actually see stuff happening live. So let's make this as wide as possible. It's a little bit easier to read. Looks like we're trying to open state channels. We have 0 active. For some reason, we haven't opened a state channel yet. Otherwise, we're checking for burns, but that's from customers. UI9. Oh, you know what happened? I know exactly what happened. We made a mistake earlier. Or, sorry, I made a mistake earlier. So what we're going to want to do is the env router. So actually, let me... I saw that there's this OUI 999 thing that happened. And that's telling me that I probably neglected. See that? So that was my hint that I done messed up. So we are OUI 22. So I'll do that. I'll do Docker compose restart. Does that do something? Yeah. Cool. So we'll wait for that to go through. Once that happens, we should be able to submit transactions. We'll just watch those live because it's kind of I think it's useful to build some understanding of how to read the logs. So hopefully I'll be able to give some good hints here. Let's see now. We're connected. This is libp2p stuff. Still 999. Docker compose stop. Maybe with the reset, the new variables didn't get captured. I don't know. I would have thought they would have checked that. Let's see. Did I save it? So env router. Okay. Let's just try it again. Actually, I also think my other window. Okay. Let's put this up. We'll leave this in the background. And here we'll tail the logs. There we go. So now the state channel's being opened. will no doubt be trying to write filters as well. And I'd imagine we'd probably see the state channel open happening in the next block. I'm not seeing any filter data being talked about. So maybe I'll try to force that again just to see if maybe it does something different. Do update. Oh, there we go. So I'll also submit the filter thing. So it's estimated to cost me 40 cents to write this. This is something you should you want to keep awareness of, is the updating the filter tables right now is pretty costly. We're working on stuff to make it a little bit easier and take a little less intervention stuff, but if you look at env router, you'll see some options here, and I think that we've disabled filter updates by default. Yeah, router XOR filter worker. So you can only do it manually, which is good because that way you can add all your devices, and you're only going to write filters when you decide that you want to. Because otherwise, you add one device, you might have like 100 devices in that filter. You add one device, it's going to cost I don't know how much, but probably more than you want to pay every time you add a single device. So this helps you batch it and then like update it manually, or with purpose, so that you're not just spending a bunch of DCs updating filters dynamically by accident. So now if we go back to the logs, there's the filter stuff submitted. Yeah, we'll get a state channel update soon. Oh, that looks good. Invalid transaction, blockchain transaction routing insufficient, DC HNT. Alright, so apparently I don't have data credits. Let's see about that. So the routing thing worked. If I go here and I look at the account, indeed, I'm broke. And let's go back to the owner. Okay, so I still have my HNT, which makes me think I probably didn't estimate the transaction fee well enough earlier. So I'm going to be a little quick and lazy about it and go back to Helium Wallet balance. This is the one, right? All right, here we go. Burn amount 8. Oh, I did 851 earlier. That's not going to cover it. Oh, it's because I had the other transaction in flight, and I forgot to account for that. Okay, so we're going to go take our OUI address. What is it? Payee. And let's review it just to make sure. Actually, 0.1 might not be enough because about 35 cents I'd anticipate. Yeah, 35 cents. So we're going to lower it a little bit further. Because the price right now is probably around 24-ish. So actually, I don't want to have this fail again. So let's go ahead and do that. Commit. Alright, now this is the one that's going to give me the money. So I'll go ahead and post this, and I'll wait for a little bit. Okay, so I just noticed that the transaction cleared. That's exciting. So now if I go to this account, which actually it's so yeah, the same account as the routing also is given the money, and if I check, we got some DCs, And now, yeah, it looks like if I scroll back a little bit, I wasn't paying attention too closely, but it looks like we got it handled. We went from no active to eventually successfully submitting that. Oh, and we got the filter in. So, I do believe, let's see. This device is still trying to do its thing. How are we doing over here? Alright, that's good. Basically, what I did was I was checking the intervals between updates. So I think what happened is the filter was updated. We submitted to the chain, and then eventually the update made its way to the light gateway that we connected to earlier with the virtual gateway. So when I did this, it was this was a light gateway that needed to get the update from a validator, and it only checks every 10 minutes. So this is all good to know that, like, expect some latencies in general when you're doing these updates. So if I start this guy up, I did stop it because I wanted to kind of see what it would look like from the beginning. But at this point, I'm happy because it's working. It's connected. It's sending packets every second. And if I go here, where was I? Yeah. If I go here, I can see my data coming in. And so this virtual device sends confirmed uplinks, and it's just going. And this is great because I've basically, I've set up an OUI. I've written my first filter of the chain, my first device. I'm purchasing packets in my state channel. It's a good starting point. So now I can learn more about. I think so. The next steps to look at as far as the docs are, first of all, like, what are all the different things you can do with console? If you wanted to set up console, you probably know a little bit about this already, but the integrations are pretty good. I listed a few earlier, but there's a lot more here. And these are the kind of low-level flexible ones that let you build whatever you want off of it. Functions are good for decoding your payloads. So if you have like a packed IoT payload and you want to make it into a nice JSON for another service, you should look into functions. And I think those are the big pieces that I like to highlight. The other thing you should look at is making your product or console, like as a product, more accessible to people. So do check this section of the tutorial of the docs. You'll learn more about how to set up these, well, specifically like SSL and stuff like that. And you will want to modify your Docker Compose to do that, which just to show you what that looks like. So we took this Docker, or no, we took the local Docker Compose. You'll want to take this section, like if you want to just add SSL, you do this. You add this, you follow the tutorial. What else do we have on this section about deploying? I think that's basically it. Yeah, so those are kind of next steps. But I think that was a good day of work.